Welcome back. I hope you didn't fall asleep in part A. And if you skipped over part A, your math career just went right down the tubes. And it's not too late to go back and redo it a little bit. But anyway, the part A has given us what we call the quadratic formula. And this formula, x equals minus b plus or minus the square root of b squared minus 4ac over 2a, is the standard form for solving any quadratic equation. Again, the idea is you can use this complicated thing, as you can see, no matter what, and get an answer. But sometimes you want to work smart, not hard. So please don't forget to look for GCFs and whether or not you can factor the trinomial into two binomials and so forth. Anyway, so we started with the standard form and we solved for x and we wound up with that, if you followed along in part A. If you didn't, this is what you have to deal with here. All right? So, how do we use it? All right? So we want to use the quadratic formula to solve for x. Here is our equation. All right? And the question is, what value for x makes this equation true? All right? And so the first thing you want to do is make sure that it's in standard form, decreasing order set equal to 0. And then you want to identify what's a, what's b, and what's c in this equation. In this equation, a is 1, b is minus 9, and c is 20. Everybody see that? From there, it's just a matter of substitution. I'm going to write the quadratic formula, except with empty parentheses. All right? And then, in these empty parentheses, I am going to put in a, b, and c where they belong according to the quadratic formula. Piece of cake, right? So this is b, right? And we said b was minus 9, so I put a minus 9 inside the parentheses. All right? Quadratic formula says b squared, so again, that's minus 9. For ac, a is 1, and c is 20. All right? Over to a was 1. All right? You with me so far? Simple substitution. We figured out what's A, B, and C, and we substituted it into this thing called the quadratic formula. Now it's oh, wait a minute. Something should look familiar to you. A blast from the past? Remember b squared minus 4ac? That thing called a discriminant that we were doing way out in lesson 115 or something like that? This should look familiar to you. Look, here's the quadratic formula, minus b plus or minus the square root of b squared minus 4ac over 2a. b squared minus 4ac. You'll remember in our discussion of the discriminant that if this results in a positive value, that there will be two solutions. If it results equal to 0, in other words, b squared is exactly the same amount as 4ac, right? Because if b squared was the same as 4ac and you subtract them, you get 0. Then there'll be one solution, and if this quantity b squared minus 4ac turns out to be negative, there won't be any real solutions. There won't be any real solutions because this is the value inside the radical sign. If this value, b squared minus 4ac, turns out to be negative, then you're trying to take the square root of a negative number and you don't have a real solution. So the discriminant, all right, comes in handy on these things. In this case, the discriminant, plugging in our a's, b's, and c's for the discriminant formula, we see that it comes down to a, c, and b, 81 minus 80, gives us a positive result, which says that when we solve this quadratic equation, we ought to have two solutions. Let's see. So we go back to our original quadratic where we filled in all the substitutions for a's, b's, and c's. All right. And we got minus minus 9, which is 9, plus or minus the square root of minus 9 squared, 81, minus 4, 81 minus 80. There's our discriminant. All right. And all of that is over 2 times 1, 2. So that x is equal to 9 plus or minus the square root of 1 over 2. Oh, that's nice. Let's see how we do that. All right, so remember that 9 plus or minus 1, which is the square root of 1 over 2, gives us two possible solutions, right? We have 9 plus or minus 1 could be 9 plus 1 over 2. 9 plus or minus 1 could be 9 minus 1 over 2. We solve this one and we get 10 over 2, x equals 5. And we solve this one, 8 over 2, x equals 4. And there's our two possible solutions. But again, be careful, they are possible solutions. All right? So let's check our work. For x equals 5, we got 25 minus 45 plus 20 equals 0. True. 5 works. For x equals 4, 16 minus 36 plus 20, 36 minus 36 equals 0. It works. So for that, this equation, x equals 5, x equals 4, is our answer. Now I hate to say it, but you could have saved yourself a lot of work if you realized that our original equation here is factorable, right? What multiplies together to make 20 in a positive way and adds together to make minus 9, we could have factored this as x minus 5, x minus 4 equals 0, right? In which case, x minus 5 equals 0 and x minus 4 equals 0, setting our factors equal to 0 using the zero product rule. Therefore, x equals 5 and x equals 4, and you would have saved yourself a whole lot of work. But that really isn't the point. The point is getting used to this thing called the quadratic formula. All right, so remember that to do the quadratic formula, you always got to start in standard form. So if you're given something like minus 18x plus x squared equals minus 32, you don't want to try to solve it like that. The first thing you got to do is rearrange things and put it in descending order into standard form, and here we have it. Once we've got that, if we're going to use the quadratic formula, we say a equals 1, b equals minus 18, c equals 32. So once again, it's just a matter of substitution. We take this quadratic formula, write it with empty parentheses, and we've got b here, minus 18, right? We've got b here as well, minus 18. We've got 1, and we've got 32 for c, right? So 1 minus 18, and c is 32, over 2a, 1. All right, so all we did was substitute in our a's, b's, and c's into the quadratic formula. And now it's just a matter of simplifying. X equals 18 plus or minus the square root of 324, 18 times 18, minus 4 times 32, about 128, and all of that is over 2. And then we can say that that is going to be equal to 18 plus or minus the square root of 196 over 2. And that's 18 plus or minus, well, the square root of 196 just happens to be 14 over 2. All right. And so now we have two equations. We have 18 plus 14 over 2 and 18 minus 14 over 2. 32 over 2, 16, and here 4 over 2, 2. So we could say x equals 16, x equals 2 for our solutions. Multiplies together to make 32, adds together to make minus 18. Yeah, we could have factored that to x minus 9 and x minus 2 and gotten the same answer. But again, the point is substitution using the formula, all right? Now, the thing is, life doesn't always give you factorable trinomials, all right? So if we were to solve this one, 5x squared minus 3x minus 1, and we plug all this into the quadratic formula, a's, b's, and c's, right? We would wind up with 3 plus or minus the square root of 9 plus 20 over 10, which is 3 plus or minus the square root of 29, which is not a nice whole number, and whatever that is divided by 10. In which case, that's the answer, and you just leave it like that, all right? Believe me, if you were to actually substitute this into here, it would work, all right? It would work. And again, this is giving you two answers, right? A 3 plus the square root of 29, whatever that is, divided by 10, and then 3 minus the square root of 29, all right? Which would be a negative number because the square root of 29 is bigger than 3. So sometimes life doesn't give you factorable things, but you still got to come up with an answer. And in fact, this answer may be not good for a hardware store, but we can certainly estimate the square root of 29 on your calculator, and then do the 3 plus and 3 minus and divide that by 10, and give ourselves some possible answers there. They're pretty close. All right. Let's take a look at this one. 2x squared plus 3x plus 4 equals 0. You might say, you're not going to fool me, I'm going to factor that. Well, good luck, because you ain't going to be able to factor it. All right. So we're left with our friend the quadratic equation, or the quadratic formula. Again, simply putting in A, B, and C into the formula gives us this idea of, I wind up with minus 3 plus or minus the square root of 9 minus 32. And all of that is divided by 4. But guess what? 9 minus 32 is a negative number. And so I get minus 3 plus or minus the square root of minus 23. Not real. Not a real solution, in which case you say that this has no real solutions. And if we had just saved ourselves some time and looked at the discriminant here, the thing inside the radical sign, we would have seen that 9 minus, whoa, that's way more than 9. That's going to be negative. You could have stopped right here and not even done all that to know that there was not going to be any real solutions. All right? This is a chance to work a little smart, but to do that you got to understand what's going on. All right? You can't just jump into things. You want to take a look, you want to see what's going on. All right? But if that fails, then you just do it. And you get the right answer anyway. All right? All right, a little physics. All right? You're standing 70 meters above the ground here at a cliff. And you're going to throw the ball with a velocity of 5 meters per second up into the air. All right? Physics can tell us how long it's going to take for that thing to hit the ground by using a simple little equation like this one. And notice that negative 4.9 t squared plus v times t plus s, that's an s, not a 5, all right? And that stands for the initial height here, s, all right? That's a negative a, which says as a parabola, it's going to open downward, all right? Which makes sense. When you throw a ball, the shape of your parabola goes up and it comes down, and it makes a downward opening parabola, right? Amazing how this stuff all hangs together, you know? So our task here is to solve for t. We want to know how long it's going to take to hit the ground. And we don't want to mess with trying to factor this. Gosh, 4.9 is factor? Nah. Instead, we'll simply use the quadratic formula. We'll substitute in a minus 4.9, b is 5, c is 70, the initial height. And we put all this substituted into the quadratic formula. We simplify it as best we can, all right? And we get this minus 5 plus or minus the square root of 25 plus 1,372, all right? Well, in this case, all right, we need some sort of answer. We can't just leave this as a radical over minus 9.8, all right? And what we need to do then is to give some approximation. And let's be clear here. If you're going to give an approximation of a non-whole number square root, you use 4 decimal places, all right? That's not just math, that's physics as well, all right? So we got this radical, 25 plus 1372, all right? It's basically the square root of 1397, which is approximately 37.3765. So this is an approximation of this square root. And now we can solve this. We can do we can do minus 5 minus 37, which is what we want to do because we're going to have to divide that by a negative. But if we do minus 5 plus 37, we're going to get a positive numerator and a negative denominator, and the answer is going to be negative, which doesn't make any sense. The ball didn't fall in negative time. So that's an extraneous solution, and we will ignore it, and instead we'll do the minus 5 minus 37.3765, and that gives us minus 43 something, and then divide that by 9.8, and that gives us approximately 4.3241 seconds for that thing to fall. All right? So in real life, you got to make an approximation of the radical. If it doesn't ask you to do that, then leave it in radical form, and plus or minus the radical is fine. All right? All right. So again, yeah, it looks worse than it does, but it's really just a matter of substitution. Plug in A's, B's, and C's, and very carefully simplify that until you get some kind of an answer. Then, if you get whole number answers, you should be able to check them fairly simply. All right. So, for your assignment on this, due next Monday, all right? This is lesson 110 out of your book. Please do A to F and 1 to 5. F, 1 to 5, lesson 110. And you might want to go back and review some of this stuff. Make sure it's in your notes. Quadratic formula is notoriously hard to remember. Make sure you've got that written in your notes someplace, all right? So that you can refer to it. Otherwise, good luck, and we'll see you later.